Hello and welcome everyone. Hello Anton. Um, I'm Andrew Tropin and I'm free and open source software developer, author of Geeks Home and RD projects, and here we talk about development tools and practices, share part of my usual workday, and travel towards a sustainable ethical business. On the previous stream, we briefly talked about enjoyment, mental health, and motivation, and did some programming, refactored test models, explore the ways to load those test models and run our custom test runner for them. And today we talk about consistency. We'll write a few tests for Lisp and ini serializers, and also maybe try out some other test runners. I talk about various topics not directly related to programming and to software design and technical stuff, because it's a good way to improve my non-technical English, which is, I would say, a little behind my technical English. So it's just a way to practice it, but also a way to share some insights, some ideas that I have, which not technical, but helps to develop a good and quality software, and also make projects better and make your life better. So I think it's worth it. But if you don't enjoy so non-technical things, just let me know. It would be interesting to get some feedback on it. And talking about consistency, it will be also a brief topic, overview of the topic. And I would like to say about two definitions, two aspects of consistency. And first one is applicable to things, to projects, to software, to user interface. And consistency in this case means that you can learn something about the project, about user interface, and after you learned a part of it, if you easily can guess how the other part of this project, interface, and so on works, that means it's quite consistent. And more technical example is language syntax. C-style languages have quite complicated syntax, and people who comes to it can spend days learning it and still be confused by some statements, some parts of source code. But when you use, for example, Lisp family languages, they are very consistent. You have only basically one thing, which is S expression. And if you learned how S expression constructed, you actually know the whole syntax of the language. Of course, it doesn't mean that Lisps are easier or maybe easy to learn, easy to program on, but it for sure makes the life much simpler when you develop Lisp programs, because you don't need to learn a new syntax or maybe some arcane syntax every time you encounter a new part of the source code. It looks very identical, but the meaning of course can change, but it's still very consistent. And I would say it's a good quality of software and other things in general. Hello, Antares. And the second meaning of consistency is regularly repeating the actions over and over. For example, when you consistently work out, you get some good results usually, and if you do it not consistently, it's often not very resultive. Of course, you don't need to repeat the same action. You can adjust the action you do. You can actually adjust the goal towards which you try to go. But if you do it on a regular basis, you can achieve actually impressive results, especially if you take into account the feedback and adjust accordingly, and try to keep and persist your results. And even small steps, but often steps, which is done daily or maybe weekly, gives you a really impressive result in the long term. And here we see a combination of three talks about feedback loops, about persistent results, and now about consistency. Taking those three things, probably a little more other things, but still having only those three things already can improve the life, the quality, the project you work on. So that's it about consistency that I would like to mention today. And let's go and do some tests for our RD project. You can always support me by sharing a word about my projects and talks. I would really appreciate it. Okay, let's actually create a new test model for Lisp serializers. And we can copy the same model definition, slightly modify it. And now let's add a copyright header here. And let's start write some tests. First of all, we will declare some model related constructions like test begin and test end for the whole model. Actually, we can try to get model name somehow. Current model, what it returns. Model name, like this. Okay, is it possible test and to do something like this. So we can just copy paste it for other models as well. Expecting string. How to convert a list to string easily? Like this. It looks so. And let's write some assert. Pop, pop. Like this. Cool. Now we want to set a test runner, I guess. We did some work here, but it's not cleaned up yet. We have test runner definition and we have test runner factory. Okay. Okay, let's re-evaluate it. No such file or directory. What? And now, okay. Now we see we run all the project tests. But the test runner is different. Hmm. Let's see what we have at test runner current. First, it's not set. Okay, that's okay. Let's see what we get from discover tests. We have a list of files. Good. We have instantiate test runner function. And let's see again what we have at test runner current. Okay, we have a test runner here. Now we call test begin. Run tests for file. And test end. Okay, test runner reset. Very good. Looks correct. And let's run the whole file. Okay, And now it works. What if we comment out those parts and restart the REPL? I would like to see how it works on a clean state. Shell. Restarted the REPL. Let's connect back to it. Very nice. And let's evaluate this file. Boom, it works. Because we know that test begin and test end and evaluates. Not evaluates, instantiates test runner. And we defined our test runner using test factory call. Let's move it closer to the place where we executed. Okay, good. Don't need it anymore. Test runner reset, current factory simple. Not needed. Some links, let's keep them. Set current test runner. Test group, here search, run tests. Okay, it was some drafts of what interface we could make, but let's revisit it later. Okay, we already can load all project tests. The output of our test runner is a little bit sparse and overwhelming. Let's remove few new lines. Okay. What else I would like to see? I would like to see the hierarchy of our test groups, so we can easily figure out the nesting of those groups. For this, we can update our test runner to do just some visuals. And on group begin, we will write not test group, but something more meaningful. First of all, let's change it to the arrow like this. Okay, and now we can change the length of this arrow depending on the number of groups nested. And for this, I would like to see what is inside test runner. Okay, let's reset our test runner Okay, we need something more nested, and here we see stack. Yep, we have stack, and we can count the number. The number of items inside the stack. Test runner group stack count, not count, or maybe count. No, not count. We need the length. Probably it should work. Yep. Like this. Okay, now it will be complaining about it again. No? Yes? Let's just reset test runner always to the new instance. Okay, we see numbers here like 0, 1, 2, etc. Now we need to generate, let's comment it out. Now we need to generate a few characters based on this length. How to do it? There are a few options, and probably probably we can do just with a format string. But I need the whole format documentation. Your format has so much functionality, so probably you can implement another programming language using just format strings. We have iterations, conditionals, so I guess we quite close to Turing complete language here. I didn't find the thing that I wanted. Object output character integer as well fixed point. It's everything about numbers. I don't need numbers. I need to repeat the same character a few times. Argument jumping. Something like this actually. But based on the argument. Okay, probably it's I either missed something or there is no such functionality. But okay, it doesn't really matter because we can construct it ourselves by fault. Do we have reduce? Oh, we have. Okay, we need a fault, and here we need a lambda, which accepts our final string and something, and we just string append str like this. And now we need I don't remember the function name which generates a sequence. It's usually called range, but it's not this range. Oops. I remember that it contains those characters, but I don't remember the actual order. Iota, okay. Here we go. It should take a string and append a few characters to it. So let's see how it works. Fault unbound variable. Okay. Let's add one model. I don't remember which one. Fault Expecting string. Why you were expecting string? Okay, let's read the documentation for it. Initial value list. Each procedure call is procedure. Oh, okay, it's vice versa. Now we have some structure. Let's make a separate function for it. Define repeat character. The character. Okay, let's call it string, repeat string. String n times. And let's call it string repeat. String repeat. String something. Okay, looks good to me. We even documented it. And let's check if it works. Repeat string. String repeat. What we have here? We have lengths here. And on group end, let's do the same. String repeat. Now you can see some kind of hierarchy, but actually I don't like it. And also I don't like the fact the way file is printed. And on group end we have a runner, and inside this runner what we have, let's see. I would like to find this one. It's group stack, and I would like to get only car from it. Like this. Or maybe we can actually do the same. Okay, it's readable. It's readable, so we can live with it. But the links doesn't work because we have our REPL launched in a different folder from our file, and we need to fix it. Whoa. Discover tests is defined here. Why? Why it tries to go to a different directory? It's strange. Oh, we actually need to fix a small thing here. Do we have such function? Yep. Good. Now it should be actually much better. I mean the test report. Now we have them on the same level, so it's more symmetrical. And we can change arrows direction. This one or this one? Okay, this one looks clearer to me. Okay, now let's fix our file loading mechanism. Discover tests. Why it tries to find discovers test definition in this directory. It's completely wrong. Actually, I wanted to discover models in the load pass instead of files, but I didn't found a registry of models. Models enabled. What is it? Oh, it's something different. Okay. current model, set current model, set model, save model excursion, resolve model. Model variable. Model ref. There are many other reflective procedures available in the default environment. But which one? How do I know it? I see model search. File name for each. Modified after load. Submodels. Model submodels. Okay, and let's now I need to learn how iterate over a hash map. We have a hash table here. Can we pretty print it? Use models. Okay, it seems there is no submodels. But what if we call resolve model RD? Okay, a little better. Hash. Wrong number of arguments to procedure. Dx. Pkx. What? I don't get it. Okay. Key value. K value. Whoa. We found something. Serializers. Cool. Cool. Very cool. I like it. So we can actually use it for now. I just use and instead of mapping over the files, we will map over models. Actually, I'm surprised that I found out this function using just completion. And it's probably not documented. No, it's not. Okay, we map using run test for model, like this. Expecting okay, run test for model actually expects model name. What's okay, it expects model name, but I actually have a model for you. Model and here we will call model name of model. Boom. Very cool. And links works, which is also much better now. Okay, the way we found it is interesting, but what about model search? Okay, doesn't work. This one doesn't work as well. How do I find the source for it. Let's restart the REPL one more time, because the behavior of go to definition is a little strange right now. Geyser connect. Okay, it's okay. Test begin. Go to definition works. Test runner default. It doesn't. What happens? I can guess. How we launch it? Brainst environment, which goes to src tests, src local, guy load pass. Looks strange. Does it work only for loaded models? Let's find out. Huh, it seems so. Only models loaded in REPL will be found. Okay, it partially works for me. And also you can see that the path changed. It contained a dot here. Probably primitive load changed some state inside the REPL. But I still don't know how model search works. Maybe I can just open a guile source code. Guix guile. And here model search. It loops. Okay, now we have a source code. I don't know why go to definition doesn't work here, but at least here we can find a lot of interesting stuff related to models. Oh, actually, not only related to models. Model modified. Okay, we have model map, which should give us ability to iterate over all models. Model map пока it requires some model. What is model ob array? Hmm. We made some progress. Models. Oh, We have root models, submodels, which can actually be useful as well. What's this namespace for ICE9 session? Okay, we can actually write a function, a recursive function, which will traverse all the models. In RD namespace, and filter will filter out only models containing test at the end. And this way we will be able to actually execute all project tests. Do you want to do it right now or not? We got a list of all root models. Here we see guix, guile, srfi, RDE. All srfi models, all RD models. Okay, for some reason it seems that guile load pass doesn't affect guix REPL. I will need to figure it out. Probably find a way to launch guile REPL the way it finds all RD models without actually loading them separately, like it does for guix. Okay, let's see what we have in guile load pass. It's percent load pass. Okay, we have why do we have rd root directory here? It doesn't have to be here. Geyser. Okay, maybe this is why. Okay, we need to reload the buffer to actually have changes from dir local applied. Okay, let's see. Geyser connect and load pass, and it's still the same. Interesting. I mean, this one looks correct. This one comes from nowhere. I don't know where it comes from. Let's launch another emacs instance. Oops. Here we have Geyser connect. And we still have it. Okay, I will figure out it later myself, I guess. Okay, let's just write an actual test. We have test runners. Let's inside this test runner. Set test runner current to false. Test runner current to false. Oops. Cool. This mutable structure for test runner is a little bit hard to track and to use, but we already have it. So let's utilize the power it provides. I would like to write a few tests for Lisp serialization code, and for this I will need to use model rd serialization Lisp. Also, I probably will need some utility functions. Okay, but let's first try to serialize sexp config, I guess. Sexp config, field name false. Hello there. Okay, it returns a G expression, and now we need to evaluate this G expression and get an actual result. So we will need guix mixed text file. Okay, now we have a text file which we need to build, and to build it we will use build with store, which is not defined. This is not defined, and it is expected. So we will create a new model test store. Don't know if it should be plural or singular. It's hard to make decisions when you're tired, and making streams sometimes make me tired. Actually, almost every time. I enjoy it, but it's really hard to talk and to program at the same time. So I spent a lot of power to do it. You know, it's actually the same for pair programming. I also getting tired much faster when I do pair programming. But let's see what we have here. Test suite, tests. And what we have in guix. Guix file test. Don't know. Let's call it tests, and later we'll rename it if it doesn't work. rd tests store sem make directory, yes, and insert something here. Tests store. Here we will export build with store, and we already have this function implemented, but in a different file which called tmp-scm, which doesn't make too much sense, the name I mean. So let's extract this code here. Build verbosity. Okay. Now we need to export all necessary models. I think this list should be enough. But interestingly, now it still works. This is expected, but I would like to be able to reset all the stale bindings in the model. So I would like to have a reload function which actually reloads the model, removes all the bindings and creates them from the actual content of the file. I will comment them out. I will restart the REPL. RD shell. And now evaluate it. Match. ICE9 match. Good. Current system. Monads for sure. Guix for sure. Store for sure. With status verbosity. I guess status. Cool. Let's paste it here. Oop. Use model. Cool. Now we have it, and let's go to Lisp tests. Okay. It works. Oh, I got it. TMP txt. Cool. Now it works as well. What we actually need here. RDs not store but build. Slurp car. Hello there. Okay. Let's call it define guix to string guix value, maybe. Glue 8 G expression now we have this function which accepts G expression and returns a string, so we can write an assert equal test equal basic list serialization. Basic list serialization. Okay, it will be hello there, just like this. Okay, backslash n. Interesting. Probably it's because of this equal. Nice. Okay, we wrote a first real test. Very nice. Today we improved our test runner a little, make it easier to track the nested test groups. Also, we made it possible to launch our test runner on submodels, and this approach is more robust than file-based, and I like it more, so I'm quite happy with it. We need to figure out load passes and how they works in Geyser and guix REPL that I use. Maybe we will switch to plain guile executable, or maybe we need to adjust something in Geyser so we can go to definition correctly and have RD models loaded correctly. And also we wrote our first real test, which creates a store entry based on our serialization function, and we compared the content of this store item with string and made sure it serializes correctly, which is very cool. And I guess we're quite productive today, but it's already hour and a half. So I will finish the stream, and as a conclusion, I would say be consistent and make consistent things. See you in a bit.